What we're now going to do is derive some new formulas, some new trig identities that we can use to help in calculations that help us with the sum of the difference of angles. So here's how I'm going to do it. On a number plane, there's my unit circle. I've got one point there which I've labelled P. I can work out the coordinates of P. If I call that angle there beta, bit of trig will work out the x and the y value for me. And so, x over 1 would be cosine beta. Oh, the x value must be cosine of beta. Y over 1 is the sine of beta. Oh, y is the sine of beta. So the coordinates of P is simply cosine beta, sine beta. And that's true for any point on the circle, as long as we define that angle to be going to the positive side of the axis. So if I had another point over here, Q, and that angle there is alpha, it doesn't become minus cos alpha, it's still cos alpha. So it's cos alpha, sine alpha, because alpha in this case now is obtuse. And the cosine of an obtuse angle, that will create a negative number. So it's still just cosine of the angle, sine of the angle. So I've got these 2 points here, P and Q. I'm going to find the distance between the two. I can do it a couple of ways. I can do it using trig, using the cosine rule. So I've got a triangle there, and the angle would be alpha minus beta. So PQ squared, 1 squared plus 1 squared, minus 2 times 1 times 1, cos of alpha minus beta. PQ squared is 2 minus 2 cos alpha minus beta. And that's where I'm going to leave it for now. If I'd done the problem using coordinate geometry, so the distance formula, then I would have said, well, PQ is the square root of, so I've made a PQ squared, don't have to worry about the square root sign then. So the difference in the x value is squared, plus the difference in the y value is squared. Expand out, and you'll notice a few cos squareds plus sine squareds that I can turn into 1. So we end up with 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. But they're both equal to PQ squared. So they must be the same thing. Well, therefore, I now know 2 minus 2 cos alpha minus beta is the same as 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. Tidying that up, I get the first of our new relationships. And the cosine of alpha minus beta is the cosine of alpha times the cosine of beta plus sine alpha sine beta. You see, we can't just expand the angle out like we would in algebra. I can't just expand it out and say, oh, that's cos alpha minus cos beta. Doesn't work. So we need this formula which allows us, if you like, to expand the alpha minus beta out. So cos alpha cos beta plus sine alpha sine beta. Well, now what I'm going to do is I'm going to replace beta with minus beta. So everywhere I see beta, I'm going to put minus beta. So it becomes cos alpha minus beta, so plus beta. Now, cos minus beta, sine minus beta, I'm now going to play with odd and even functions. Okay. If you remember, cos or cosine is the even function. So the cosine of minus beta is the same as cosine beta. Whereas sine, that was the odd function. So sine of minus beta will be minus the sine of beta. So I can tidy this formula up now. Cos of alpha plus beta is cos alpha cos beta minus sine alpha sine beta. Very similar formulas, but you'll notice when it's plus here, it's minus there. And when it's minus here on the left-hand side, it's plus. So the way I remember it, right? It goes cos cos, sine sine. Okay, cos, sine, sine. If it's not the sine, it's cosine, it's not the sine, then it's not the sine. Get it? See? So, because it's not the sine, then over in the other one, it's not going to be the same sign. So, Cos, cos, sine, sine. If it's not the sine, it's not the sine. Oh, we'll get there. We'll get there. All right. Now, going to go back to that first one we derived. This time, I'm going to replace alpha with 90 minus alpha. So we get cos 90 minus alpha minus beta equals cos 90 minus alpha cos beta, sine 90 minus alpha sine beta. This time, I'm going to play around with the idea of complementary ratios. The cos of 90 minus alpha is the same as sine alpha, and vice versa. So we could tidy that up. Now, 90 minus alpha minus beta, I can factorise here and get also a complementary ratio, 90 minus alpha plus beta. So my cos of 90 minus alpha plus beta, I can turn into sine alpha plus beta. The cos of 90 minus alpha, I can turn into sine alpha. And the sine of 90 minus alpha, I get sine beta. So the sine of alpha plus beta is sine alpha cos beta plus cos alpha sine beta. But now I'm going to replace beta with minus beta to create another formula. And so we get sine alpha minus beta, sine alpha cos minus beta, cos alpha sine minus beta. Let's take advantage of odd and even functions again. What do you notice? When it was a plus on the left-hand side, it's a plus on the right-hand side. When it's a minus on the left-hand side, it's a minus on the right-hand side. That would be the same sign. So that brings me to this. Sine, cos, cos, sine. Sine, cos, cos, sine. If it's the sine, then it is the sine. So cos, cos, sine, sine. If it's not the sine, it's not the sine. And sine, cos, cos, sine. If it's the sine, it's the sine. Now, all you got to remember is cos, cos always goes together. Right? Cos, cos always goes together. And the first one you say is the one you're working with. So sine is what I'm working with. So I start with sine. Sine, cos, cos, cos always goes together. So it's sine, cos, cos, sine. If it's the sine, it's the sine. Whereas when I'm doing cos, I start with what I'm working with. Cos, cos, cos always goes together. Cos, cos, sine, sine. If it's not the sine, it's not the sine. Well, let's have a look at tan. Let's see what happens. Tan, of course, we can rewrite as sine on cos. Now, on the top, sine alpha plus beta, we now know what that is. That is, of course, sine cos, cos sine. If it's a sine, it's the sine. The bottom of the fraction, that will become cos, cos, sine, sine. If it's not the sine, it's not the sine. That's a little bit complicated to remember. So I'm going to make it even more complicated. Here we go. Let's divide everything by cos alpha cos beta. However, there's some cancelling that now happens. See, look, cos beta cancels with cos beta, cos alpha with cos alpha. But of course, sine on cos is tan, and we get this lovely formula. Tan of alpha plus beta, tan alpha plus tan beta, are 1 minus tan alpha tan beta. Well, you know what I'm going to do now, because we've got to complete the set. We're going to replace beta with minus beta. And all we've got to do is work out, tan, odd or even? Odd. So the tan of minus beta is the minus the tan of beta. Have a look at this one. Basically on top it stays the same, the bottom it changes. So how do I remember this one? Well, there we go. It's tan plus tan on 1 minus tan tan. Tan plus tan on 1 minus tan tan. And then I just remember that one. And so if I want the other one, then I just change the signs. I just remember. That's what we call the sum and difference of angles. So there they are. Sine, sine, cos, cos, sine. Cos, 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 sine, sine. 10 plus 10, or 1 minus 10, 10. Let us do some examples. Right. Before you walked in this room today, you would have looked at that and went, what? But now it's easy. It's cosine. Cosine is, of course, and I know you want to say it, cos, sine, sine. If it's not the sine, it's not the sine. Voila. Simplify this one. Now, many mistake has been made with this question, because they look at tan 20 and they think, hang on, how can I create 20 out of angles I know? But actually have a look at what you got. You have got tan plus tan on 1 minus tan tan. It's tan of 20 plus 10. Tan 30, which is an exact value, 1 on root 3. If we now had to work out the exact value of sine 15, sine 15, don't know what sine 15 is, but there are ones that I know that I can create 15 out of. There's different ways I could do it. I could go 45 minus 30. I could go 60 minus 45. I mean, there's lots of different possibilities. So I'm going to go 45 minus 30. It's sine. Sine is sine cos sine. If it's the sine, it's the sine. Sub in the exact values that we know, and there we go. There's our exact value. Root 3 minus 1 on 2 root 2. Okay. Can your calculator do this one? We're told sine alpha is 2/3, cos beta is 1/4. We have to find sine of alpha plus beta. Don't make the mistake of thinking alpha and beta are in the same triangle. They're not. They would definitely be different triangles. So how I solve this one myself is I just draw up the two triangles, work out the third side they haven't given me, and there's beta, and just simply sub in the formula now. So sine cos sine, read off the different triangles, sub in, bingo, we got an answer. 2 plus 5 root 3 on 12. All right, let's have lots of fun.